Okay, this is the 7.5 quiz. This recording will have 7.5 to 7.8, inshallah, for chemistry. I think the rest is all recorded. As usual, I always advise you to go through the notes. Please go through the notes. Please, like I'm telling you, please go through the notes. I will record the notes the day before the chemistry exam, so probably on Sunday. I'm telling you, go through the notes because stuff always comes from the notes. Again, please go through the notes. They're more important than the book. Let's start. 7.5 is about the alkali metals, the Li, Na, K, Rb, and Cs. Question 1, what's true about them? They're solid metals. They're soft. They react violently with chlorine. They conduct electricity. You know this. We've had it in many AMSs. The alkali metals. And what's one thing? As you go down, remember for noble gases, as you would go down, the group for noble gases, usually the boiling point would increase. But here, as you're going down, uh, I don't know why they have it left to right. As you're going down the table, okay, it's decreasing. Okay, atomic number shows more increases, the mass increases, but the boiling point decreases. Okay, it's the opposite to noble gases because this could come in the exam. Um, then the flame test. Okay, for the flame tests, incel CLBRI, Li, Na, and K. Upon heated by a flame, Li gives a red color, Na gives you a yellow color, and K gives you a lilac or violet color. If you put purple, you get it wrong. Please don't put purple. Please. Okay. Uh, yeah, you memorize it. So LiCl gives you a red flame because of the Li. NABr gives you a yellow flame because of the Na. And Ki gives you a lilac flame because of the K. Question 2. Hold up. Question 2. As sodium reacts with water, hydrogen gas is produced. Look, these alkali metals, they have reactions with chlorine, water, and hydrogen. Okay. Uh, yeah, they're all in question 3 here. So you have to write the reaction. So I'm not gonna let you memorize because in the book they give you a rule. Okay, you can memorize the rule, but I don't like memorizing. I always like understanding. Okay, ف let me show you how to do it. For the reactions, and you're going to use this for the following sections also in 7.8 or 7.7, I forgot, but you're going to need to use this way. So I didn't, yeah, I didn't take the question. My fault. Okay, look here, write the equation for potassium with chlorine. Okay, potassium K plus and chlorine Cl minus. Okay, obviously we're going to form KCl, right? So before looking at before writing down the equation, what I like to do is for chlorine, for oxygen, I like to find the compound that I'm going to form. Since it's plus and minus, same charge, they cancel out, which is going to be KCl if you crisscross, huh? So your compound formed is going to be KCl. How do I write this? It's potassium with chlorine, yeah? K, usually you should put plus, but here they're not requiring. Forget about the plus, let's just put K for potassium. With chlorine, yeah? So plus Cl. But chlorine, is diatomic. It's always Cl2. So chlorine is always Cl2. To produce KCl, like over here. Okay, state symbols. Potassium is a solid since it's a alkali metal, so the metals are solids. Cl2, we said it's chlorine is a gas. Everybody knows chlorine is a gas. And KCl, it's an ionic solid, right? Potassium and Cl, like NaCl, which is salt. This is also a solid. Let's balance now. K, it's good. Cl2 here, so we have to put 2 here. Okay, but here we have 2K now, so we have to put 2K. Okay, like this. That's it. Yeah, that's it. Potassium with oxygen. K plus, O2 minus. Crisscross, you're gonna get K2O, صح? For now, let's write it. K plus O2. Why O2? Because oxygen is diatomic. To produce K2O. Balance it. What are the state symbols? K is a solid because it's alkali metal. Oxygen, is gas. And K2O is gonna be a solid. It's a solid because, am I record? Yeah. It's a solid because it's a metal and a non-metal. Metal, non-metal gets you ionic solid, huh? Uh, Now balance this 2O here, so we need 2O's here. Okay, 2K2 here, there's 4K's here, so we have to put a 4 here. That's it. Potassium with water. Water is a special one, okay? For the alkali metals with water, you get the alkali metal OH. Okay, so I'm gonna use Na. I'm gonna use Na and water. Okay, uh, ف yeah, since here they're talking about potassium, and I'm gonna give you one from me. I'll use NAs. Okay, so just so you understand the rule. Since it's potassium with water, water isn't an element, so there's no crisscross. Okay, but you have to memorize that any alkali solid, let's call it the alkali solids ALs. Okay, any alkali solid plus water gets you the base, and the compound formed is the alkali solid OH. Okay, that's you have to memorize it. So it's the alkali hydroxide. So what does that mean? Let me show you. Let's say I'm doing Na and H2O. Okay, let's write it down. Na plus H2O to produce. What's the compound being produced? Always when it reacts with water, you get the alkali hydroxide. So alkali OH. So Na and always OH. That's the compound produced. Plus, you always have hydrogen. Okay, you have to memorize this. Okay, think about it over here. You see, the way they write it is weird. If you write it like this, you also get it correct, but the way I write is also correct. So plus hydrogen, always plus hydrogen. The energy part isn't really asked, but in case and it's asked, there's always energy being given off in all these reactions. Okay, always there's energy being given off. In case they ask, they don't usually ask. So this is the rule. Anything with water from the alkali solids, once they react with water, it produces the alkali hydroxide. Hydroxide is OH plus hydrogen gas. Okay, now let's put the state symbols. Na is obviously solid. H2O is liquid. NaOH is gonna be aqueous because it's ions. Okay, because NaOH is the same as saying Na plus OH minus. Okay, because since they're ions, it's always aqueous. Okay, and H2 is gonna be gas. Okay, let's balance it. Na is balanced. H2O. Here you have two hydrogens. Here you have three hydrogens. So you have to put a 2 here. Gets you 2 NaOH. Here you have now 4 hydrogens, yeah? So you put a 2 here now to balance out the hydrogens. You have 2 oxygens here, 2 oxygens here. Here you have 4 hydrogens. Okay, it's balanced. But here you have 2 Na, but you have to put a 2 here. Is it the same thing? Yes. That's how you write these reactions. Okay, this is 7.6. It's easier, not easier. It's a bit hard. It's a bit trickier, but it's long. It's long. Uh, which of the following explain why hydrogen is diatomic? Okay, look, for bonding, it's about the bonds. This whole section is about the bonds. Hydrogen has an atomic number of 1. So it has, say this is the hydrogen, it has 1 electron, right? It has to bond with another hydrogen, right? And they form a bond, right? So you get H2. But why? Do you ever ask yourself why? Let's take a look at the periodic table, yeah? Periodic table. Uh, Look here. Whenever you're, and I've explained this before, I think, whenever you're bonding any element, the the goal after bonding is to have the same chemical properties as the neighboring noble gas. So let's say we were talking about Na and Cl, yeah? When Na bonds with Cl, Na loses an electron to become like neon, to have 10. And then when Cl gains an electron, it becomes like argon, to have 18. But whenever you have bonding, the main objective is to get the same chemical properties as the neighboring noble gas. Look here, when H atoms share electrons, each one feels like 2 electrons around it. Why? Because H is 1, yeah, 1 electron. Another H has another 1 electron. The bond, now it has 2. It's stable like helium. If we put stable like argon, you'll get it wrong. It has to be like helium. Why helium? Because helium is the neighboring noble gas. So it has 1. It gains another 1 from the other hydrogen, becomes 2, which is like this helium over here. Okay? How about water? Okay, how is water stable? Water has H2O, right? Each H feels as if it has 2 electrons because it's 2H, right? 2H. So 1 electron, 1 electron. How does it look like? Looks like helium. Each O feels as if it has 10 electrons as neon. You know that O over here in the periodic table has 8, right? It has 8. 8 is the atomic number, hence it has 8 electrons. But you know that O is 2 minus, right? O2 minus. So it gains 2 electrons and becomes 10. Like who? Like neon, right? So it has 10 electrons like neon. And then both atoms H and O achieve the number of electrons of a noble gas. Why? So it becomes stable. I told you, every time when you have a compound being formed, they try to achieve the same configuration as the noble gas all the time, okay, to become stable, because the compound has to become stable. And for this one, for the each O feels 10 electrons, like when you have H2O, it looks like this, okay? H, O, H, it has a bond like this, a bond like this, I think. Uh, this O has 8, it takes one from here and one from here, I think. Well, I don't know, how does it look like? Yeah, it looks like this. For the O takes one from the hydrogen, one from the hydrogen here. Okay. Uh, المهم, let's continue. Question 2. Oh, this one's easy. Like here, Cl, it has 7. It's gonna bond to another Cl, because you know Cl is Cl2, right? Why does it bond like this? Uh, because it needs to get 8, right? It has to bond like this. Now it has 8 over here, 8 over here. In total you need Cl2. It's a single bond. Oxygen is 6, right? Here, this is 6. It's going to bond 1 here, and it's going to bond 1 here. Now, 6 plus 2, 8. Nitrogen is 5. It needs to bond 1 here, and 1 here, which is triple, 3. It's always sharing since it's a covalent bond, okay? Question 3, spontaneous, non-spontaneous. Okay, look. The halogens, the spontaneous reaction, I explained this in one of the AMS quizzes. I forgot, I think week 9. Probably week 9. FCl, Br, and Fickelbury. I think it's these, yeah. And then you have astatine here. Uh, the thing is with these halogens, when you have a spontaneous reaction, it's always uh, the neutral halogen, okay, plus the halide. Okay, the neutral one always has to be more reactive. More reactive. So it's gonna be halogen 2 plus halogen minus. The halogen that has 2, which is the neutral one, always has to be more reactive. Okay, in the halogens, as you go down, the reactivity decreases. Okay, reactivity decreases. The most reactive is fluorine, and the least reactive is astatine. Let's look here. Cl2 plus 2Ki. They try to confuse you with the K, with the K. Okay, forget about the K. Now what we're looking for here is the halogens, right? So we're looking at the Cl and we're looking at the I. Which one's my neutral one? It's Cl. And you know the neutral one's supposed to be more reactive. Is Cl more reactive than I? Yes, it is. It's above I. This is correct. It's spontaneous. How about the one under it? I2 plus 2KF. Again, forget about the K. We don't care about that. Okay? I2 and F. Which one's neutral? It's I2. Okay, they should. They're not putting minus because they put it with K. If they put it with K, you don't. They don't have to write the minus. المهم, my neutral one is I2. The rule is that the neutral one has to be more reactive than the other one. Is I2 more reactive than F? I2 is down here, I is down here, but F is up here. So is it correct? No, because F is above I. So it should be F2 plus I. Okay. Then Br2 plus 2KCl. Again, my neutral one is Br, and the halide is Cl. Okay. Uh, is Br more reactive than Cl? Br is down here, Cl is here. Cl is more reactive than Br. That means this cannot happen. It's non-spontaneous. شوفي كمان. Sometimes they give it differently, okay? In this quiz, they didn't give it like this, but look, sometimes they put, because this came in the written part last year for grade 10s. Let me say NaCl plus Br2 to produce let me think. NaBr plus Cl2. You have to say, is this spontaneous or no? Okay, look, if they put Cl first, it doesn't mean that one's the neutral one. Okay, Please don't get confused. Just because they put it first doesn't mean it's the neutral one. The neutral one is the one with 2. In this case, Br is the neutral one, right? And Cl isn't. Is Br more reactive than Cl? It goes FCl Br IAT. Is Br more reactive than Cl? Br Cl. No, it's not. Cl is more reactive. Hence, this is non-spontaneous. Okay. Another way they got it was like this. F minus plus Cl2 to produce Cl minus plus F2. Spontaneous or no? Let's see. The neutral one is not F. Just because they gave F first doesn't mean it's neutral. Cl2 is my neutral one. Is the neutral one more reactive than F? You know, F is at the top. فأكيد Cl is not more reactive, hence it's not spontaneous. Please don't get mixed up with these, okay? They try to trick you يعني. Question 3 أيوه. is question 4 3 did I just do 3? Yeah, I did 3. Question 4. Okay. They gave you 3 here, 3 elements here. What you want to look at is the outer shell. You have 1, 2, 3, 4, 5, 6, 7. This one has 7. You have here 8. If you count them, 1, 2, 3, 4, 5, 6, 7, 8. And you have 1 here. Let's look at the periodic table. You know, the ones with 7 electrons are group 7, which are my halogens, right? And then the ones with 8 electrons are my noble gases. And then the ones with 1 electron are my, no, H is not included, are my alkali metals. When we're looking at these elements here, A, B, and C, when they say 7, that means they're talking about halogens. A is a halogen. When they have 8 here, that means B is a noble gas. And C here, when it has 1 electron, it's an alkali metal. So C is an alkali metal. So we have to now fill these in. Soft and malleable. Which one's soft and malleable? You know, soft and malleable means they're talking about alkali metals. Which one from these are alkali metals? We said C because it has 1 electron. Unreactive and highly stable. Which ones are unreactive? You know that the noble gases are unreactive. Which one here is the noble gas? We said B because it has 8 electrons. Which one forms a diatomic gas? It's A because the halogens all form diatomic gases. Okay, let me show you. The diatomic gases, they're all halogens. F2, Cl2, Br2, I2. AT doesn't really count. But halogens are the ones that form diatomic gases. So it's A, since we said it has 7 electrons. A. It forms an ionic compound with bromine. Okay, ionic compound, معناتها they need a metal because you know ionic compound is metal plus non-metal. Okay, bromine is the non-metal, yeah. Bromine, which is by the way in group 7, no need to know that. So bromine is the non-metal. So they want an ionic compound, so they need the metal, yeah. Which one's a metal from A, B, and C? If this is a halogen, this is a noble gas, and C is the alkali metal. Actually, it's going to be C because we need something to complete the ionic compound. We need a metal to complete the ionic compound with bromine. So it's going to be C because C is the alkali metal. It reacts vigorously with water to form hydrogen gas. Which ones here react vigorously? Halogens don't react vigorously. Noble gases don't react at all. But we know that alkali metals react with water from the previous section, 7.5. Okay. Remember we said that an alkali metal plus hydrogen gets you the alkali hydroxide plus hydrogen gas. F, it has the lowest boiling point. Obviously, noble gas, because they're always gases. Noble gases are always gases. Okay, but they have the lowest boiling points. Question 6 or 5 قصدي. Okay. They put here, I don't know why it looks like this, but they put Cl, they put I, and they put Br. Okay. You had to complete it. Which one's white? It's Cl. Which one's yellow? It's I. Which one's green? It's Br. One way I remember, I told you guys to memorize. For the yellow, you memorize it ILY. Same way as I love yellow. It's iodine loves yellow. And then for creamy, Cr is Br. That's how we memorize it. Okay. And then which one's left? It's chlorine. The white one's left. We just give it to chlorine. So in the written, if it comes, which one forms a white precipitate? Okay, you put chlorine. Which ones? If they said that it formed a yellow precipitate, remember iodine loves yellow, so you put iodine. I minus. You have to put the charge, huh? Because we're talking about the charged. It's aqueous. Write the net ionic equation for the reaction taking place in tube 2. Okay, look, we're adding AgNO3. Okay, they want the net ionic. Okay, the net ionic. This is forming a precipitate, yeah? You know that the precipitate is a metal plus non-metal. Okay, they want net ionic. You remember net ionic, you only talk about the predominant. Predominant, yani the ones that are actually taking place in forming this yellow precipitate. For this test, this is actually known as the test of adding AgNO3. You're always adding AgNO3. We're adding AgNO3 to all these tubes. Okay, but they're forming precipitates. But they only want the net ionic, so they really don't care about the NO3. They only care about the Ag. In this white tube, it's actually AgCl. In the yellow tube, it's AgI, and in this creamy tube, it's AgBr. Okay, so they want you to write the net ionic taking place in tube 2. Since the precipitate in tube 2 is AgI, okay, AgI, silver iodide, we want to write the net ionic. How would you write the net ionic? Remember how I told you? First write your precipitate, then draw an arrow. What do I write? Ag plus I minus. These are the charges. Ag plus, by the way, is the charge for silver. Uh, it's a metal, but it's positive. And then the state symbols, akid, since they're ions, it's always aqueous. And then AgI, it's precipitate, and you know precipitates are always solid. Okay, but that's how you do it. Anytime they ask you to write the net ionic, and I think this will come صراحة in the written, you do Ag plus, you're always adding silver, plus whatever halide you have. If it's Cr, if it's creamy, you write Br minus, and then you put AgBr. And akid solid, aqueous. Question 6. What is yellow-green? Chlorine. Which one's a shiny solid? Iodine. Which one's a brown liquid? Bromine. At room temperature. Because look here, these are actually the notes. Okay. In a pure state, at room temperature. Okay. Fluorine is yellow. Chlorine is yellow-green. Br is reddish-brown liquid. Iodine is a solid. Okay. And then astatine is a black solid. They won't ask astatine. Then these you have to memorize them. Look, in water, chlorine is colorless. Bromine in water is brown, and iodine is also brown. What they would do is, since they're both brown in water, how would you distinguish between iodine and bromine? They add carbon tetrachloride, okay, which is CCl4. So once you dissolve in CCl4, what distinguishes them is that here, for the bromine, it becomes orange. But for the iodine in CCl4, it becomes purple. That's how you distinguish between iodine and bromine. Okay, you'd say, what about room temperature? Usually, you never have them in the pure state. Okay, you never have halogen in its pure state. You always have it mixed with something. To distinguish between them, we add CCl4 between bromine and iodine. Bromine becomes orange, iodine becomes purple. Question 7. Write the chemical formula of X. Okay, they're saying in the flame test it became yellow. What becomes yellow when using the flame test? We said that Na from the previous section. If it's yellow after the flame test, then it's Na. Then they added silver nitrate. Silver nitrate is AgNO3. They added this AgNO3 and it became a yellow precipitate. Which one's yellow? We said iodine because iodine loves yellow. For what's this? It's NaI. Okay. Question 8. Ya Allah. I don't know why it's tweaking, but wait, let's do one first. Give the chemical reaction between hydrogen gas and chlorine gas. Okay, hydrogen, forget about this. Don't memorize, please. Hydrogen, you know, is H2. Chlorine, you know, is also Cl2. For H2, which is a gas, plus Cl2, which is also a gas, to produce, obviously, HCl, right? Since it's H plus Cl minus crisscross, you're gonna get HCl, which is a gas. Balance 2H, 2Cl, here you have to put 2HCl. Okay, very easy. Then they're saying what happens if you add silver nitrate, AgNO3. We said if you add silver nitrate to chlorine, you get a white precipitate. But it should be a tube, and then they should write here white precipitate. white precipitate. I don't know why the photo isn't showing. Question 9. Give the chemical equation for the reaction of sodium with chlorine gas. Okay, sodium is Na plus Cl to produce a white solid, which is obviously NaCl. Okay, let's balance this. You know, Cl is always Cl2, right? I should have wrote Cl2. Na is a solid since it's an alkali metal. Cl2, you know, is a gas, chlorine gas. NaCl, since it's a solid, they said it's a white solid, so it's solid. Let's balance it. 2Cl here, that means you have to put 2 here. Since there's 2 now sodium, you have to put 2 Na. So this is how it is balanced. Then question 2. Choose the correct type of the solid formed. It's an ionic solid. Why is it ionic? Because it's a metal plus non-metal. What is molarity and concentration? You know, concentration is C equals N over V. For 0.45 over 0.75, because this has to be in dm cubed. If you divide by 1000, it becomes 0.75 and you get 0.6. Question 10. Okay, the hydride formed from an alkali metal. So using the periodic table here, the hydride formed from an alkali metal. Hydride means the compound. Okay, the compound of hydrogen with what? The alkali metal. What alkali metal do we have here? We have Na. So Na plus the hydride, which is hydrogen. What do you get? So obviously NaH. The chloride formed from an element that loses 3 electrons. So chloride means we're talking about chlorine, right? From an element that loses 3 electrons. What element loses 3 electrons? You know, if it loses 3 electrons, that means the charge of it is 3 plus. And which one is 3 plus? It's the ones in group 3, and in this case it's Al. So you have Al3 plus Cl minus. You know, Cl is minus. Crisscross, what do you get? AlCl3. Part C, let me go down. The oxide formed from an element that loses 2 electrons. Okay, the oxide formed, so oxygen plus the element that loses 2 electrons. If it loses 2 electrons, يعني 2 plus, yeah? Because it becomes positive. If you lose electron, it becomes positive. Which one's 2 plus? Obviously, it's the one in group 2, which is calcium. For calcium, Ca2 plus oxygen, which is O2 minus. You know, oxygen is O2 minus. Crisscross, they cancel 2 with 2, you get CaO. Question D, part D. Most stable element in the third period. Okay, third period. What does period mean? This is the first period. This is the second period. This is the third period. What's the most stable element? You know, the stable elements are all the noble gases. For which one do we take? We take the one in the third period. First, second, third. So we take argon. Question 11. The reaction between a halogen, such as chlorine, and hydrogen is exothermic. I told you this. All the reactions are exothermic because since you're forming a compound, and also they said plus energy, which is they're forming energy in the product, so it's releasing energy. But it's obvious, yani exothermic. Question 12. The cation and anion. Okay, look. A salt solution is subjected to a flame test, and the flame test turned red. Red means lithium. When they added silver nitrate, it became creamy. What does creamy mean? Br. Cation. Cation means the positive one. Obviously, lithium is the metal, so it's going to be positive. And the anion, yani negative, which one's going to be negative? You know, lithium is plus, Br is minus, so it's going to be bromide. So lithium is the cation, and the anion is bromide. What's the chemical formula? If it's Li and Br, akid is LiBr, because Li is Li plus, and Br is Br minus. Crisscross, you get LiBr. Part 2, what's the net ionic equation of the precipitation reaction? Okay, the net ionic, since we're talking about the creamy precipitate. Okay, the creamy precipitate, yani we got Br, yeah? And we're adding silver nitrate. I told you for the precipitation reactions for the AgNO3, the silver nitrate stuff, for the creamy and the yellow and the white, it's always Ag plus Br minus to produce AgBr. Okay, the states are aqueous, and then solid, because this is a precipitate. Question 13. A salt S is dissolved in water. When a silver wire is dipped, and then they put it on a flame, the color of the flame became yellow. What does that mean? Yellow flame, Na. When a few drops of silver nitrate are added, a white precipitate forms. Which one's white? Yani Cl. Okay, which slowly turns purple, then black. This doesn't matter. Here they're just trying to trick you. we only care about the precipitate after being added to or after being subjected to AgNO3. What is the chemical formula of S? Since it's a yellow flame and the white precipitate, it's Na and Cl, so NaCl. What is the formation of the precipitate? I told you it's always Ag plus Cl minus get AgCl. It's always Ag plus the element you have minus to produce the precipitate. They said do not include state symbols, so you keep it like this. Question 14. A white solid M was dissolved in aqueous solution Z. To a few milliliters of Z, a little chlorine water was added. Okay, the solution turned brown. When 2 milliliter of CCl4, so it became brown, huh? Tab, okay, what are my two brown ones? Remember, they're bromine and iodine. Tab, how do we know which one's which? We add CCl4. Remember, if you add CCl4, you can distinguish between iodine and bromine. So now they added CCl4. What happened? It became purple. What does that mean? If it's purple, it's iodine. Because if it was bromine, then it would have turned orange. When a platinum wire and then placed in a flame, the color of the flame became lilac violet. What did we say that was? K. Potassium is lilac violet. For what is the chemical formula? It's Ki. Potassium iodide. Walid, why isn't it Ik? You're not allowed to put the non-metal than the metal. It has to be metal, non-metal. That's it for 7.6. Hala 7.7. Okay, 7.6, it's three questions. It's very easy. It's all about the properties of hydrogen. Okay, the first one, what's true about hydrogen? It has the second lowest boiling point and is diatomic. Is it an alkali? Obviously no. Does it have the highest melting point? Obviously no. Is it yellow-green? No. That's chlorine. Question one, easy. Question two, question three, um, they're about the reactions. Okay, the reactions of hydrogen are very similar to the ones we've done. Okay, so like look, for example, when you have uh, sodium, an alkali metal plus hydrogen, it's very easy. Na plus H gets you NaH. Or how about the reaction of NaH? The main two you have to know are these. Well, it's three, sorry. This, and this. Okay. The alkali metal plus hydrogen gets you alkali hydride. The alkali hydride plus water gets you hydrogen gas, similar to the, remember when we had NaCl plus H2O, we got this the alkali hydroxide plus hydrogen gas, same exact thing, but this time you have Na and OH. I don't know why. It should, in the quiz they didn't allow me to write it. Like in the quiz they only wrote, it's question 2 I think. In the quiz they wrote it Na and OH, they separated it, but you should be allowed to write it as one complete one. I don't know why they didn't let me. المهم until we get there. And then with chlorine it's very easy. H2 plus Cl2 gets you HCl. I'll show you how to do them. Question 2, look, let's start. Write the equation of sodium with hydrogen. Sodium and A plus hydrogen, H2, which is a gas. Sodium is a solid, huh? Because it's an alkali metal. Na plus H gets you NaH. Why? Because Na plus H minus crisscross, you get NaH. Top, now let's balance two hydrogens, so we have to put two here. Two Na now, so put two here. And since it's an ionic, it's a metal with a non-metal, that means it's a solid. Question 2, calculate the volume of hydrogen to react with 4.6 grams of sodium at RTP. Okay, look here. RR and GR. This is my reaction. What's given? Okay, 4.6 grams of sodium. How many grams of sodium do I have here? I have 2 times 23, because Na is 23, yeah? 2 times 23, I have 46 in my RR. My GR, what's given? 4.6. Okay, we want volume of hydrogen at RTP. Okay, in my reaction, how much volume do I have? I have 24. Because you know, RTP means Vm equals 24. And since I have 1 mole of hydrogen in the reaction, it's 1 times 24, which is 24. So what's my GR? We need to figure it out. You cross multiply and you get 2.4 liters. That's it. Question 3. Write the net ionic or the ionic of the reaction that takes place between the products formed in part 1, so NaH, and water. For NaH plus H2O. This is solid, this is liquid. What's the first thing? The first thing produced, I like putting hydrogen gas at the end, but the first thing produced, okay, look, and I'm not sure because I put in, you should be able to write NaOH شو اسمه why dipole minus. You should be able to write NaOH aqueous and then H2 gas. Okay. Yes, here even I'm looking at the notes. It should be allowed to put it as one. Okay. ف if you want, you can put it as NaOH. So NaOH plus hydrogen gas. Okay, I like keeping the hydrogen gas at the end. It doesn't matter. But if you want it, if they want it in the computer, put hydrogen gas at the start. It shouldn't matter. يعني it shouldn't matter because حتى in the other one, uh, the quiz with the alkali methods, we were allowed to put hydrogen gas at the end. المهم, it's the rule. Whenever it's reacting with water, it's the alkali hydride plus hydrogen gas. And let's balance. There's nothing to balance. Na is balanced. Here you have 3 hydrogens. Here you have 1 and 2 more, so 3 hydrogens. Here you have 1 oxygen. Here you have 1 oxygen. So it's balanced. Question 3. Write the equation that takes place between hydrogen and chlorine. Hydrogen is H2, gas. Chlorine is Cl2, gas. Produces H plus Cl minus. Crisscross, you get HCl. So produces HCl, which is also a gas. Okay, is it balanced? H2 Cl2, you need to put a 2 here. Now is it balanced? 2H2Cl, yes, it's balanced. So it's correct. Calculate the number of moles that reacts with 4.48 liters of hydrogen gas at RTP. Again, RR and GR. RTP, that means Vm equals 24. So RR. In my RR for hydrogen, how much volume do I have in the reaction? It's 1 mole times 24, because RTP, huh? So 24 in my reaction. In my given ratio, what's given? 4.48. This is term 1 stuff. يعني how to calculate term 1 stuff. What do they want? They want the number of moles of chlorine. Chlorine, in my reaction, I have 1 mole. In my given, I don't know, it's X. If I cross multiply, you get 0.187 to 3 significant figures. That's it for 7.6, for 7.7. Okay, now we're on 7.8. This is the last section, and it's mainly it's this whole table. Okay, this section is this whole table. It's basically the reactions of the period 3 elements. Okay, because in the periodic table we have periods, rows. This section studies period 3 and their reactions with hydrogen, chlorine, and oxygen. These are the 8 elements. المهم, you have 2 options. You can memorize the table. Okay, you can memorize each one and what the reactions are, or you can understand. In my opinion, understanding is way easier. Okay, but there are a few exceptions that you have to memorize. Okay, the first uh, the first exception, okay, is this here, AlCl3. Okay, actually, I'll go through them one by one. Okay, I'll go through them one by one. Okay, the reaction of sodium with hydrogen, it's a hydride. Let me go scroll up a bit. Okay, with a hydride, sodium with hydrogen is NaH, because Na plus, H minus, crisscross, NaH. Mg with hydrogen, Mg2 plus, H minus, crisscross becomes MgH2. The 2 goes down here. Al and hydrogen, Al3 up, hold up, Al3 plus and H minus, crisscross becomes AlH3. Silicon is 4 plus. Okay, memorize this. Okay, you have to know that. SiH4, silicon, Si4 plus and H minus. The 4 goes down, becomes SiH4. Phosphorus is 3 minus because it's in group 5. It goes P3 minus and H plus, crisscross, pH3. Sulfur is 2 minus since it's in group 6. S2 minus and H plus becomes SH2. Except for sulfur and chlorine, okay, if it's reacting with hydrogen, you write it as the hydrogen first, then the element. Instead of saying SH2, you have to say H2S. Okay. Then chlorine, which is Cl minus and H plus, becomes ClH. But can you write it as ClH? No, because we said chlorine and sulfur, you have to write the hydrogen first. For H can be HCl. Then they talk about the type of compound and the type of bond. They're all ionic. I mean, not they're all. Sorry. These first three are ionic because it's a metal with a non-metal, metal with a non-metal, metal with a non-metal. Silicon is not a metal, okay? Silicon is a non-metal, and it forms network solids, okay? It forms a network solid with oxygen. That's in the book, okay? Once we get there, we'll talk about it. بس المهم silicon non-metal non-metal molecular non-metal non-metal molecular non-metal non-metal molecular non-metal non-metal again molecular. Argon has no reaction for everything because it's a noble gas. You guys know noble gases, they don't react, okay? Uh, Now for with the chlorides, Na plus Cl minus, you get NaCl, Mg2 plus and Cl minus, you crisscross becomes MgCl2. This is the exception you need to memorize. Okay, what's different about this? Okay, أول شيء Al3 plus and Cl minus, if you crisscross you do get AlCl3. So there's nothing wrong. But the exception you have to know is Al2Cl6, okay? But that's it's there's a chance they could write for you Al2Cl6 and it will still be correct, as they say here, because AlCl3 dimerizes under certain conditions to form Al2Cl6. Dimerizes يعني it just changes form. So sometimes AlCl3 might change its form into Al2Cl6. Okay, uh, okay. This is pretty straightforward, except the bond. Okay, the bond for it is molecular, and sorry, the compound is molecular and the bond is covalent, because uh, it's just an exception. You can't. There's no because. It's just an exception. Okay. You'd say, but oh, it's a metal, non-metal. No, it's an exception. You have to memorize it. SiCl4, Si4 plus Cl minus crisscross becomes SiCl4. Straightforward. PCl3, uh, it it could be PCl5. This exception you have to memorize because it's P3 minus. Wait, sure, P3 minus and Cl minus. You crisscross, it becomes PCl3, right? Okay, but if you also write PCl5, it could be correct. Okay, so if they put PCl5 for you, make sure to know it. Okay, so I'm gonna circle the ones you have to memorize. Okay, these are the exceptions. S2Cl2 also is an exception. You say because sulfur is usually S2 minus Cl minus, it should be SCl2, no? But this one's an exception which you have to memorize. It's S2Cl2. Okay, so I'll circle that all. Cl2 is obvious. Chlorine plus chlorine gets you Cl2 gas. Everybody knows this. Okay, let's continue. Na plus O2 minus because we're talking about oxides. The 2 goes down, so it'll become Na2O. Mg2 plus O2 minus, the 2's cancel, so it'll become MgO. Okay, Al2. By the way, Anna, when I'm talking about the cancel and the charge, I'm just not writing it because I think you guys should know it. So that's why I'm not writing it. They cancel out MgO. Al2O3, Al3 plus, O2 minus, crisscross, 2 goes here, 3 goes here, Al2O3, SiO2, this is an exception, okay? Silicon forms a network solid with oxygen and its formula is SiO2. But it's still a covalent bond, because network solids have covalent bonds. P4O6 and P4O10, this is definitely an exception, okay? You have to memorize this. Phosphorus with oxygen gets you P4O10 or P4O6. Then for sulfur, uh, sulfur, this is also an exception. You have to memorize sulfur plus oxygen gets you SO2. SO2 is actually sulfur dioxide. Most people should know what sulfur dioxide is. If you take bio, you should know what sulfur dioxide does. Um, Also, this obviously is an exception. Chlorine with oxygen is Cl2O or Cl2O7. Other than that, there's nothing else to memorize. The table is very straightforward, Saraha. Most of it you can understand, like literally most of it. And the ones to memorize aren't even that hard to memorize. I'm gonna go to the next tab. Go back to the quiz. Which of the following are ionic compounds? NaCl, obviously, MgCl2, obviously. AlCl3 is able to metal and a non-metal. But no, we said that's the exception. You see, we said it's an exception. It's molecular. SiCl4, obviously not because it's non-metal, non-metal. Cl2, obviously not. It's non-metal, non-metal. Question 2. Uh, which ones are covalent compounds with hydrogen? Okay, magnesium, obviously that's a metal, so no. Aluminum, it's a metal, no. Sodium, it's a metal. Silicon is a non-metal, and phosphorus is a non-metal, so we pick them because We want covalent compounds. Covalent يعني non-metal plus non-metal. Question 3. Okay. How do you find the number of electrons? It's the same as finding the number of protons. You just subtract the mass number from the neutrons, and you get the number of protons, which is equal to the number of electrons, because it's an atom, which is neutral. فالمهم 20 minus 10, 23 minus 12, 24 minus 12, 19 minus 10, 40 minus 20. You get these. Which of the following are isoelectronic? Isoelectronic يعني I've said this before, I think, same number of electrons. Okay. What does this mean? Let's see. Ne has 10. Okay. Na plus. يا عمي وطي صوتك وطي صوتك يا حبيبي ادم خلاص وطي صوتك. Na plus means it loses an electron. Okay. يعني if it's 11 it loses an electron, it becomes 10. So this is 10, this is 10, so we pick it. Mg2 plus يعني it loses 2 electrons. Okay, so 12 it becomes 10. So we also pick it since there's 10, 10, 10. F minus means it gains an electron. So this 9 gains 1, so it becomes 10. So you pick it. Okay, but Ca2 plus you don't, because 20 you lose 2, it becomes 18, and that's not the same as these 4. Okay, so we pick these 4 only. Question 4. The chemical formula of the compound that's expected to form when Mg and Cl react. Okay, without memorizing tables. Mg2 plus Cl minus crisscross, you get MgCl2. And obviously it's ionic because magnesium is a metal and Cl is a non-metal. Question 5, and this is the bad one. Yeah, okay. This is the one. I'm convinced. I know a question like this will come will definitely come in the exam. Let it be written or let it be multiple. It will come. Okay. Sodium with sulfur. Na plus S. Okay. Na plus S2 minus. 2 minus. Crisscross becomes Na2S. Magnesium with chlorine. Mg2 plus Cl minus. Crisscross MgCl2. Aluminium with oxygen. Al3 plus. That's 3 plus. And O2 minus. Crisscross Al2 O3. Silicon with oxygen. Si and oxygen. This is the exception, remember? So it will be SiO2. Remember I said the silicon with oxygen is an exception to become a network solid, which is SiO2. Silicon. Silicon with chlorine. So Si4 plus and Cl minus. Crisscross SiCl4. Sulfur with hydrogen. S2 plus, S2 minus قصدي, and H crisscross, you get H2S. Remember, you have to write the hydrogen before the actual element for sulfur and for chlorine. Argon with hydrogen, obviously no reaction because argon is a noble gas, so there's no reaction. For here they're just repeating themselves. They're asking about the bonds. Is it ionic? Is it molecular compound? Whatever. Okay, sodium with sulfur Na2S. Well, you don't have to look at that. Sodium with sulfur. Metal, non-metal, أكيد ionic, ionic. Metal with non-metal, ionic, ionic. Metal with non-metal, ionic, ionic. بس إذا حطوا, if they put aluminium with chlorine, remember that exception was molecular. Okay, even though it was metal, non-metal, that was the only exception that would have been covalent. But here they didn't put it, so it's ionic, ionic. Silicon is oxygen, non-metal, non-metal, covalent, network solid. Network solid, not molecular, network solid, because we said silicon with oxygen, SiO2, is a network solid. Silicon with chlorine, شو اسمه, non-metal, non-metal, covalent, molecular. Sulfur with hydrogen, it's covalent, molecular. Okay, again, because non-metal, non-metal. Argon with hydrogen, Na, because there's nothing here, no reaction. Thank you so much for watching. Good luck, and I'll post a video on Sunday, I think. If our exam's on Monday, then I'll post on Sunday for the course revision and the notes. Thank you so much. Good luck.